just converting things. So let's talk a little second about verbal models. A verbal model describes a real-life situation using words as labels and using math symbols to relate the words. You can replace the words with numbers and variables to create a mathematical model, such as an expression for the real-world situation. I want to point out a couple of little words here. This first one, a mathematical model, right? Remember what a model is. A model is like something that represents something. Like you have a car model. It's not actually a car. It's just a little car, right? It's just like models who model in fashion magazines. They're not like real people. They're fancy people that we don't need to worry about, right? They're not real people. They're just models of people. They're not who people really are. So models represent things like other things could be. So if we're taking a mathematical model, what we're saying is we're going to create an expression mathematically that represents this other thing. So let's do something. We work with 5 other people at an ice cream stand. All the workers put their tips into a jar and share the amount in the jar equally at the end of the day. Write an expression for each person's share in dollars of the tips. So what we mean by making a verbal model is that we want to use the words that we're saying up here, right, to create that expression. So, for example, hold on, pause a second. It's a pause. Sometimes it's weird recording these videos because I feel like I'm talking to an actual person, even though I'm not talking to an actual person. I had somebody walk in on me while I was recording this video earlier, and it was really awkward because I was talking to the whiteboard, facing the whiteboard, and they were just kind of staring at me while I was facing the whiteboard, talking to the whiteboard to people that aren't there. It was a little bit awkward. So verbal model, we're going to take the words of this situation and we're going to create something mathematical, right? So what do we have? We have the amount in the jar, right? If we're talking about needing to split up the tips, we know that the amount in the jar is the total amount of money that we're getting for tips. And we also have the number of people. And I'm just going to write the number sign there, the number of people. Because the number of people is going to tell us just how much everybody gets, right? If there's $5 in a jar and only one person, that one person gets $5. Whereas if there's $5 in a jar and there's 2 people, they get $2.50. To find out exactly how much everybody's going to get, you need to take this amount in the jar and you need to divide it by the amount of people. So notice this verbal model that I've created here. I'm not writing the math out yet. I'm writing out the situation. I'm writing about what we're talking about. I'm talking about there being a certain amount of money in a jar and a certain amount of people. And if I divide those things, I end up with the amount per person, which is what we're looking for. So now let's go back and give these things labels, right? So what's the amount in the jar? Well, let's look back at our problem. Do they tell us the amount of chips in the jar? Nope, doesn't look like it. So because they don't tell us that, it means it could be anything. I'm just going to call that A. And I know that I need to divide A by the number of people. So let's go back and look how many people do we have. 5 other people. So that's 5. And so there's my expression, right? A divided by 5 will equal the amount of each person's share for the amount of tips. Notice that we're trying to get, this tries to get us to think about the problem a little bit, right? To think about the situation and what is happening. Not just, the answer, right? I'm trying to get a whole look about what is happening with this situation, and I'm trying to put words to it so that I can then create a model that represents those things, right? A is the amount of money in the jar, right? That's the symbol that represents this. The number of people was 5 because they told us that up here in the problem. So we're trying to create a model. We're trying to use our words to translate, right? That's what our goal for the day said, right? Our target for the day was to translate this sentence into something that we can just represent in 2 symbols or any number of symbols. Let's do our last thing today and talk about a rate. A rate is a fraction that compares 2 quantities. That should actually say, that should actually say 2 quantities, right? Not 2. That's a misspelling. Measured in different units. If the denominator of the fraction is 1 unit, the rate is called a unit rate. So remember, denominator, when we're talking about a fraction, it's numerator over denominator, which I've also, by the way, thought kind of sounds like a super villain name, right? The denominator. Yeah, kind of weird. Anyway. So, couple of keywords to look at. Keywords like per and for every usually indicate that there is a rate going on. For example, miles per hour. That per is a keyword that tells us that something is going to be a rate. And rates here take the form of a fraction. So miles per hour means miles per hour. And you should also be thinking that that per is your fraction bar, right? If it says like jumps per minute, then you're going to have jumps per minute. And that is a fraction. We're taking the number of jumps divided by the minutes. If I were to say the number of cats thrown per dogs thrown, right? Cats thrown, because for some reason we're throwing pets. I don't know. Versus per dog thrown. That means like for every 1 dog that I've thrown, I'm gonna throw 4 cats, right? If this was 4 over 1, that would be for every 1 dog that I've thrown 4 cats. And I don't know why I dislike cats more than dogs, but you know, it's just a thing. Let's do an example problem before I start talking more about cats and dogs and get arrested. A car travels 120 miles in 2 hours. Find the unit rate in feet per second. So there's a few things we've got to do here that are going to make things a little bit interesting. So first of all, we notice that there's a rate going on, right? Miles per hour, but we need to convert this to feet per second. So miles per hour, I can say that I went 120 miles in 2 hours. That's 120 miles per 2 hours, right? Well, if I'm trying to find the actual like feet per second here, I need to convert miles to feet, and that's a lot of feet. Something that you might need to know to do this is how many feet are there in a mile. Well, as it happens, I know how many feet there are on a mile. You might not know this, but you might have to just look it up. There are 5,280 feet per 1 mile. And so this is going to help us to convert this into feet instead of miles. But in addition to this, I also need to convert the hours to seconds, which that's going to take a little bit. But I got to multiply something again. This is going to be for every 1 hour. By the way, this is multiplication. I am multiplying it. For every 1 hour, I have 60 minutes. I'm gonna run out of space. I wonder if I can take this whole thing. Can I do this? No, I can't. Oh, what did I just do? I broke everything. Stop it! Oh, I gotta go back to where I was. Oh. Hey, look, there I am. Okay, we're gonna pretend like that didn't happen. So I'm gonna run out of space, but I'm gonna try to do this. So this is gonna convert it to minutes, but that's not what I need because I need feet per second. So I need to do another rate times for every 1 minute. I have 60 seconds. And if I multiply all of these things together, and man, that kind of looks messy. But if I multiply all of these things together, we should come up with our feet per second rate. So let's do it, okay? Multiplying fractions, multiply the top. So that's 120 times 5,280, and that's 2 times 60 times 60. If you have something this large, I'm not going to feel offended if you use your calculator to do it. But when you do this, you will end up with 88. And then we know that that's feet per second. Feet per second. So I will have some practice problems. I know this whole thing is probably pretty confusing, right? And I totally get that. We're going to do a couple of them. We'll make sure that we do a few together. Because yeah, how did I come up with all of this? I know that that's probably the weird part. So this one is a little bit more complicated. But right, we'll do some examples together to make sure that we get it. Okay. I think that's it. What you need to do next is on the Google Classroom. So you can finish up the video here and head back. Thank you, and I will talk to you guys, well, whenever.